You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better, but as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nga and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a mega-thrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis, like the one in 2004, are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. See this weird grayish lump lying on the ground and steaming? Well, what are you waiting for? Run as fast as you can. It can burst right into your face at any moment, leading to horrifying consequences. A disaster is unfolding in front of your eyes. At first, the ground starts trembling. A deep rumbling sound echoed through the valley. Then, boom, the volcano explodes, hurling glowing rocks high into the sky. Among them is a blob of molten rock, fresh from the Earth's fiery depths. As it's soaring, the blob begins to change. The cold air wraps around it, hardening its outer layer, while the inside remains hot and gooey. Some of its neighbors are different. Some have gas bubbles trapped inside. Others have solid rock cores, and a few stretch into long, twisting ribbons. The biggest of these flying blobs are as large as a small car. For 10 long seconds, the lava blob is flying and twisting and tumbling. Below, people begin to realize the extent of the danger and start scattering. It's useless. Flying blobs can travel for miles, up to 6 miles away to be precise. Then the moment comes. The lava blob slams into the ground. Some of its smaller companions have cooled completely and landed with a thud, but this one is still burning inside a crystalline container called a bleb. As it strikes the earth, its hard shell cracks and molten lava oozes out, sizzling and steaming, spreading out like a giant fiery pancake. The eruption is past, but the danger remains. Lava bombs, though fascinating, are among the most dangerous tricks of a volcano. The insides of the biggest blobs remain blazing hot, still bubbling with energy. They're not just warm, the temperature inside reaches hundreds of degrees. If one of these fiery projectiles struck a person, it would crush them instantly. Even worse, lava bombs can blow apart or cause secondary explosions in 2 cases. If the lava bomb has volcanic gases, like water vapor, CO2, or sulfur gases inside, rapid cooling can trap them. When pressure builds up, it can cause the bomb to burst. Or, if a hot lava bomb lands in water or ice, the sudden temperature change can create steam explosions, sending debris flying. Lava blebs come in different shapes, depending on how fluid the magma was when it was ejected. Their forms are also shaped by how they travel through the air and how they land. Ribbon blebs form when very fluid magma is thrown out in long, stretchy blobs. As these break apart in midair, they create thin ribbon-like fragments that land intact. These blebs often have fluted textures and small air pockets inside. Spherical blebs also come from highly fluid magma, but instead of forming ribbons, they're shaped by surface tension, which pulls them into nearly perfect spheres as they cool. Spindle or almond-shaped lava blebs start off similarly to spherical ones, but as they spin through the air, they stretch into elongated football-like shapes. One size usually ends up smoother than the other, showing how it moved when it fell. Cowpie blebs, yep, the real name for them, form when very liquid lava doesn't cool before hitting the ground. Instead of solidifying in the air, it lands while still molten and flattens on impact, spreading out in irregular roundish shapes that resemble, cow patties. There are also bread crust blebs that occur when the outer layer of a lava bomb hardens during flight while the inside remains hot. As the interior expands, it cracks the hardened shell, giving it a texture similar to the crust of a loaf of bread. Cored lava bombs have a hardened shell surrounding an inner core made of older volcanic rock, pieces from an earlier eruption, or even fragments of the surrounding landscape. Whatever shape a lava blob takes, you should watch out for one during a volcanic eruption, even if you're miles away from the epicenter. But lava blebs aren't the only danger you should watch for when wandering around volcanoes. Sometimes, when small drops of lava are thrown from a volcano, they can stretch into thin, elongated shapes as they cool. If they form small, teardrop-like shapes, they're called Pele's tears, after the Hawaiian volcano and fire deity. If they become longer, thinner strands, they're known as Pele's hair. In this case, you can notice something that looks like golden mats of fine hair covering the ground. These aren't strands of human or animal hair, but delicate threads of volcanic glass. They form when gas bubbles in lava burst, stretching the molten rock into long hair-like fibers. Pele's hair can be incredibly thin, sometimes just 1 micron thick. But at the same time, they can reach up to a couple of feet in length. They are so lightweight that the wind can easily carry them through the air. Later, they settle in low-lying areas, sometimes piling up in thick layers. Now, despite their delicate appearance, these strands are actually tiny pieces of glass. They are sharp and brittle, and if they get on the skin, they can cause irritation. If they get into the eyes, they can be even more dangerous. That's why it's very important to be cautious when around Pele's hair. Now imagine a tidal wave of fire and ash racing down a mountain with unstoppable force. This is a pyroclastic flow, a fast-moving surge of scorching gases and shattered rock that buries everything in its path. These flows can stretch for miles, moving as fast as a racing car and reaching temperatures hot enough to melt metal, up to 1800 degrees Fahrenheit. Pyroclastic flows strike without warning. The collapse of an erupting volcano's towering ash column or a lava dome, a massive plug of hardened lava sitting at the volcano's mouth, can easily trigger one. The moment it gives way, the fiery avalanche is unleashed, rolling down the slopes with terrifying speed, vaporizing forests, flattening villages, and incinerating anything caught in its path. There is no outrunning a pyroclastic flow. It is the most fatal force a volcano can unleash, responsible for claiming over 90,000 lives in the past 400 years. That's 1/3 of all volcanic fatalities. Not only do these flows burn, crush, and suffocate, but they also destroy buildings, bridges, and anything human-made. While scientists can predict the most likely paths, usually along valleys, history has shown that powerful flows can jump ridges, sweep over hills, and strike areas we once thought were safe. Volcanic lightning isn't as dangerous as a pyroclastic flow, but it's a breathtaking view. It forms only in the thick ash-filled clouds that erupt from certain volcanoes. These towering columns, called volcanic plumes, shoot up into the sky when a volcano releases massive amounts of ash. Not all volcanoes create these plumes. That's why volcanic lightning is rare. For example, the volcanoes in Hawaii mostly erupt with flowing lava rather than thick clouds of ash, so they almost never produce volcanic lightning. Now look at these tiny ash particles. Before an eruption, they're squeezed together inside the volcano under extreme pressure. But when they burst into the open air, they collide and rub against each other in a process known as friction. This friction charges the particles, just like when you rub a balloon on your hair. As these charged particles rise into the air, they start to separate. Positive charges move one way and negative charges move in a different direction. When the difference in charge becomes too great, the energy bursts free as a lightning bolt, cutting through the volcanic plume. Some of the most devastating consequences of a volcanic eruption are lahars. A lahar is a powerful, fast-moving river of mud, ash, and rock that rushes down the slopes of a volcano, destroying everything in front of it. These terrifying mud flows form when heavy rains mix with loose volcanic debris. When lahars sometimes happen during an eruption, they can also strike without warning. This makes them especially dangerous. Like pyroclastic flows, lahars move fast, sometimes traveling hundreds of miles. They can bury entire towns, sweep away bridges, and wipe out roads, leaving behind a deep layer of mud and rock. One of the most devastating lahar disasters happened in Colombia in 1985 when the Nevado del Ruiz volcano unleashed a mudflow that buried the town of Armero, taking the lives of over 23,000 people. Another tragic event occurred in the 1990s when lahars and pyroclastic flows from the Soufriere Hills volcano wiped out the capital city of Plymouth, causing $500 million in damage.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma ray bursts. You can't come across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes.
Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega-tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, It will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the mega-thrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first, because they blend into the mist. But once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
Kiev, you've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast. In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sundogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moondogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water.
We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern U.S. and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the U.S. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the U.S. wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But, with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super-sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now. Hey, ever heard of a fire rainbow? Yeah, me neither. How about a circumhorizontal arc? Didn't think so, but just so you know, they're one and the same thing. At first glance, it looks like a painting, or like a rainbow-colored splash in the sky. Despite the name, they have nothing in common with either fire or rain. This phenomenon happens on rare occasions when the sun shines through a particular type of ice cloud formation. The rainbow halos are just as unique. Again, a specific type of ice crystals in clouds needs to be present for the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that moon halos are usually white and sun halos can be rainbow-colored. When visiting regions with high altitudes, you may be one of the lucky people to stumble upon penitentes. They're basically naturally formed ice spikes. For them to be formed, they need a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor rather than melting it into water. And that's why these blades of snow and ice start to pop up on the surface of the Earth. As cute as they may be, they can end up as tall as 15 feet. Now, what happens when small individual droplets of lava meet the wind? Pele's hair, basically. Let me explain. The word Pele comes from an ancient Hawaiian symbol for volcanoes. Whenever the wind picks up little drops of lava, it stretches them into hair-like strands, similar to the process of glass wire creation. These delicate strands can stretch as far as 6 feet. On rare occasions, it can rain without any clouds. But does it really? Let's look at the science behind this rare phenomenon. It's sometimes called a sun shower, just because it looks like the rain is falling straight from the sun. Let's be clear though, there is no way rain can ever come down directly from a star. Rain clouds are at a bit of a distance from that specific location. With sun rays being angled, the clouds become out of sight. Add a little wind to blow the rain in your direction and ta-da! You get sun showers. Located in Bolivia is a place called Salar de Uyuni. It's the largest salt flat in the world. It's also the home of half of the world's lithium, which is a crucial component for making batteries. But what else is so special about this place? Well, whenever the rain season comes, it turns this piece of flat land into a perfectly reflective mirror lake. What comes to your mind when you hear about the Blood Falls? A horror movie? Well, they are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special kind of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets the air. Hence, the reddish color of the waterfall, which also gives it its trademark name. Okay, we all know the song, but it's not really made up. There is actually such a thing called a desert rose. It's not a plant though, but a unique form of the mineral gypsum. It develops in dry sandy places that can occasionally flood. This constant switching between a wet and dry environment lets the gypsum crystals emerge between grains of sand, trapping them and forming a rose-like shape. Ever heard of the Eye of Sahara? Scientists are still trying to figure out how it was formed. You can only see it if you fly above it, but it's basically a naturally formed dome that dates back to approximately 100 million years ago. And no, I wasn't around then. It has a rough diameter of 25 miles and consists of a bunch of concentric rings. The biggest one, or the central area, measures about 19 miles in diameter. Astronauts were some of the first people to notice it, and it's been studied ever since. In fact, even to this day, when landing in Florida, they know they're almost home when they see the Eye of Sahara. One of the most beautifully colored trees in the world is located in the Philippines and Indonesia. It's called the rainbow eucalyptus. It got its name because of its bark that switches colors and peels away as the tree ages. The bright green bark is the youngest, as it contains a substance called chlorophyll, usually found in leaves. It then switches to purple and then to the color red. And finally, it turns brown as it grows and loses the chlorophyll. Now, don't be tricked into thinking that's a whole forest. It's one single tree. And no, it's not some sort of optical illusion either. Let me explain. Underneath that soil, there is a complex network of roots that connects around 47,000 tree-like shapes you see above the ground. It's called the quaking aspen. Some of these trees are among the oldest and largest organisms in the world. Now, here's a good destination for all travelers, or maybe not so good after all. The most lightning-stricken area in the world, according to recent data released by NASA, is Lake Maracaibo in Venezuela. Out of all the days in a year, 300 of them feature thunderstorms in this location. What makes this area so unique, though, that storms happen so often? Well, it's because where cool mountain air meets the warm, moist breeze and generates electricity over the lake. The Eternal Flame Falls are located in upstate New York, near the Canadian border. In this region, there is a tiny waterfall with a big secret, a spark about 8 inches tall. Turns out there's a natural gas seep that provides fuel to the flame behind the waterfall. The waterfall provides enough coverage so that it stays lit pretty much every time. Hikers do enjoy to relight it if they see that it's been blown out. This phenomenon is actually quite common, but this one gained more popularity because it is younger than most. And it looks very good in pictures, let's be honest. I've heard of yellow sand, white sand, and even black sand here or there, but I've never heard of green beaches until now. Papacolia, also known as Green Sand Beach, is located in Hawaii and is one of the few beaches in the world that features green sand. The unique coloring comes from olivine rock that was formed when a nearby volcano erupted. Actually, in Hawaii, all the volcanoes are nearby. Move over green sands because some of the other beaches around the world can even glow at night, and it's completely natural. The culprit? A little thing called photoplankton, or microalgae as they're sometimes called. They're basically little plants that contain chlorophyll and need sunlight in order to live and grow. Most photoplankton kinds are able to float in the upper part of the ocean, where the sunlight can still reach them beneath the water. When the photoplankton gets agitated by the movement of waves and currents, they emit light, which looks like some glow during the night. These special microorganisms are found on beaches in a lot of places around the world, such as the Maldives, Puerto Rico, and the Everglades. At the base of a mountain located just outside of Afton, Wyoming, is a little river called the Intermittent Spring. There are only 3 of this kind in the whole world, but what makes this little string of water so mysterious? Well, the fact that it starts and stops every few minutes. Scientists have yet to pinpoint precisely why this happens. They speculate that it's basically just a siphon effect that happens deep within the ground that causes the river to just start and stop so often. Should you ever be interested in checking it out, be sure to do so in the late summer, as that's when the intermittent spring is most active. Do you see the irony here? You can only see the spring in the summer? Okay, I'm done. The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal, but you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island, and what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean, and you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taubo volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Taubo you already know about, Japan's Eri Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption.